Welcome to Math with Mrs. Bibb. Today we will be learning about rational exponents. Rational exponents are exponents that are expressed as a fraction. When you have a fraction exponent, this means you have a radical. Or also referred to as a root. And I want to draw you a little picture. And please draw it as well. And it's not normally like that. So when you have the radical symbol, that's what this is. This is the radical symbol. When you have a radical symbol, the number that's underneath here is called the radicand. That's the name of it, radicand, C-A-N-D. And then the number that's here is called the index, also called the root. And then you have your radical symbol. Let's talk about what rational exponents look like. If you have a base raised to a fraction exponent. I like to draw a little picture, and I'm going to use blue for what would be brown. I like to draw. I'm not a very good artist. I just try something here. If you'll please draw that too. And again, my blue is like what would have normally been brown. I'm going to go back to blue. What did I draw there? What did I try to draw? I'm not an artist. I'm just a mathematics educator. What did I try to draw? What's the blue and what's the green? What's all together? Hopefully you could tell that that's a tree. And the little blue things at the bottom are the roots. So it's my way of trying to get students to learn that the denominator tells me the root of my radical. The denominator tells me the root. So we'll talk about that in just a minute. The denominator of the fraction is the root in a rational exponent. And then the numerator tells me the exponent for base A under radical. Now I'm going to show you what I mean by that. So A to the B divided by C is equal to, put your radical symbol, put C as your root, and then A is the base raised to the B power. So I'm going to scribble a couple over here. If I have A to the 1/2, that means I have a radical symbol. A goes inside the radical to the first power, and the understood 2 for square root is there. A to the 1/2 is the square root of A. B to the 1/3 is the cube root, because 3 is in the denominator, of B to the first power. C to the 3/4 means the 4th root, because 4 is in the denominator, of C raised to the 3rd power. That's what rational exponents are. They are radicals with exponents. Now, we know, and I know you've learned this, that the square root of 100 is 10. The reason why the square root of 100 is 10 is because what is called nth roots. If A to the n is equal to B, then A is the nth root of B. For example, 2 squared equals 4. Then 2 is the square root of 4. I'm going to change that to square root. Square root of 4. Okay. We know that if you have an even root, or n is an even number. Please fill that in. Then you're going to have more than one answer. So if you're solving x equals, x squared equals 4, and we know from nth roots, if x squared equals 4, then the square root of 4 is equal to x. So the one thing that I have to remember about this is, I kind of translate it into common terms. What number can I square and get 4? Or what numbers can I square to get 4? And that would be, x could be positive 2 or x could be negative 2. But in this section, you're going to be learning principal roots. And the principal roots are only the positive ones. You do not worry about the ones that are not principal roots until you are actually solving equations where you have to take the square root. And then you have to consider both of them. Now, one thing that I like to do before I get started, I like to make myself a list. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And I'm going to go all the way to 10. 5, 6, 7, 8, 9, 10. I'm going to square those. Then I'm going to literally square them. 25, 36, 49, 64, 81, 100. And then I like to do 1 to the third power, 2 to the third, 3 to the third, so on and so forth. I'm going to do that all the way to 10. And then 1 to the fourth power, which looks like 14. 1 to the fifth power, 1 to the sixth power, 1 to the seventh power. I think I'm just going to go up to 7th. So let's see. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed I think is 216, 7 cubed is 343, 8 cubed I don't know, 512, 9 cubed is 729, and then 10 cubed is 1000. So if you will go through and fill these in through 10 for each of those, for the fourth power, fifth power, sixth power, and seventh power. I'm going to pause the video and do that, and then I will record for a moment so you can see it, and then I'll carry on. Okay, I did not go all the way to 10 on all of those. Those numbers got so big, I decided not to. And I used a calculator, so hopefully if you did it, we got the same numbers. If you did not, please talk to me. But please write those down. They will be perfect for our reference for what we're going to be doing. Example 1. The first thing we're going to do is rewrite each radical or exponential expression in their opposite form. So I want to show you that a to the b divided by c equals the c root of a to the b power. This would be called radical form. And then this would be called exponential form. So for example 1, letter A, I want to rewrite 10 to the 1/2 power, which is already in exponential form. I want to rewrite it in radical form. So remember, to do that, you put a radical. Your denominator is your root, so you put a 2 here, but it's not necessary to have the 2. It's okay for it to be gone. And then you have 10 raised to the first power. So 10 to the 1/2 is the square root of 10. This is my radical form for the exponential form, 10 to the 1/2. Letter B is the square root of 7k to the second power, and I want to rewrite this radical form, so this is radical form. I want to rewrite it into exponential form. Now, 7k to the second is all raised to the square, is all under the square root. So that means that it's raised to a rational exponent, a fraction exponent. I will have a root of 2 on both of these because they're both under the square root. And then I'm going to put an exponent of 1 there. So 7k squared raised to the 1/2 is the square root of 7k squared. I am going to do my power of a product here. I'm going to say I have 7 to the 1/2 times k to the first power, because 2 times 2 over 1 is just simply 1. So 7 to the 1/2 times k is my exponential form. When we do these examples, you're going to be very thankful that we made the reference that we did earlier. It was a lot of writing and it was sort of painful, because I agree, I did it as well. So, but you're going to be thankful. The next thing we're going to do is we're going to evaluate each expression. I'm just going to write evaluate. Letter A, the fifth root of 243. If you will look at that reference that we made and look at all of the column that has fifth power, do you see the number 243 in that list? And yes, you do. 3 to the fifth power is 243. 3 to the fifth power is 243. And that comes straight from that reference for nth roots. So, if 3 to the fifth power is 243, then 3 is the answer to that problem. And that's really all I expect you to have. So you may have to remake that list that we have. Something that I do when I don't have a list like that to look at, then I start with 1 to the fifth power is 1. 2 to the fifth power is 32. And then I think about 3 to the fifth power. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. So sometimes you can make the list as you go along. But anyway, it's very nice to have that list while we're doing work. Now we're going to do the fourth root of 625. So if you'll look at the list that has exponents of 4, I want to find the number 625 in the exponents of 4. And hopefully you see 5 to the fourth power is 625. So if 5 to the fourth power is 625, the fourth root of 625 is 5. That's my answer. For the next one, we're going to evaluate again, except this time I have it written as a fraction exponent. 4096, this is the first one, raised to the 1/6 power. That means I have the sixth root of 4096. Now if we'll look at our reference, look at the column that has 6 as an exponent, and I see 4096 there. 4 to the 6th power is 4096. So that means the sixth root of 4096 is 4. So it's the base that's being raised to that power of 6. That's going to be your answer. Now letter B looks a little different. It's 81 over 256 raised to the 1/4 power. So remember, we need to do this power of a quotient. That means I have 81 to the 1/4, and I have 256 to the 1/4. Rewrite that as a, rewrite the rational exponent as a radical. The fourth root of 81 to the first power divided by the fourth root of 256 to the first power. And then let's look at the column that has 4 as the exponent. And I do see 81. I'll write it here. 3 to the 4th power is 81. So the fourth root of 81 is 3. Then I see 256. It says 4 to the 4th power equals 256. So that means the fourth root of 256 is 4. And the next one, 100,000 to the 1/5 power. So that means I want the fifth root of 100,000. So looking back at our reference for nth roots we have, look in the column that has 5 as the exponent that the numbers are being raised to, and you'll see 10 to the 5th power equals 100,000. So then that means that the fifth root of 100,000 is 10. So there's my answers as you can see them. We're going to evaluate on these next ones, and it's really not more complicated. It's just you have to learn the form that we have. We're going to evaluate expressions of powers of nth roots. So my first one is 729 to the 5/6 power. Now, the way we were taught to write it, we were taught to write the sixth root of 729 to the 5th power. But I want you to know that this is also the same thing. The sixth root of 729, the entire thing, raised to the 5th power. It will make it so much easier if you write it the second way and not the first way. And then what we'll do is we'll evaluate the sixth root of 729. So we'll go to our reference of nth roots, and we will look in the column that has raised to the 6th power, and we will find the number 729. So I see 3 to the 6th power equals 729. So I know the sixth root of 729 is 3. And then I need to raise that to the 5th power. Well, my answer is there also. 3 to the 5th power is 243. So that's my answer to 729 to the 5/6 power. Now we're going to do 36/49, letter B. We're going to do 36/49 to the 3/2 power. Okay, so first thing I'm going to do is do my power of a quotient. 36 to the 3/2 divided by 49 to the 3/2. And then I'm going to write that as the square root of 36 to the 3rd power divided by the square root of 49 to the 3rd power. And I do not want to multiply 36 times 36 times 36. So I'm going to rewrite that to look like this. The square root of 36 raised to the 3rd power. The square root of 49 raised to the 3rd power. The square root of 36 is 6. Then I'm going to raise that to the 3rd power. The square root of 49 is 7. Then I'm going to raise that to the 3rd power. We can go back to our reference to the column that has the 3rd power, and 6 to the 3rd power in that space says 216 for 6 to the 3rd power. And then 7 to the 3rd power is 343. So that's my answer, 216 divided by 343. That is my answer to 36/49 raised to the 3/2 power. And that is our introduction to rational exponents. Hopefully it made a little bit of sense, and we will talk about it further in class. I hope you have a wonderful day.